Hello, my dear friends. Tonight we shall be looking at a scenario-based question that is coming from applications of indices and logarithms. So let's go. Kampala's electricity consumption has been growing exponentially at a rate of 7% per year due to rapid urbanization. In 2023, the city consumed 1,200 megawatts. The Uganda Electricity Transmission Company Limited (UETCL) needs to project future demand to avoid blackouts. The tasks that we have at hand is to write an exponential growth formula, and it has been given to us as P of t equivalent to P naught times 1 plus R power t. And then we are told that where P naught is equal to 1,200 megawatts. This value that is given to us in 2023. That's where we are starting our projection from. And then we are also given that, and R is equal to this rate. 7% is 7 out of 100, which is 0.07. Now, they want us to write the model or the formula for exponential growth of this consumption in Kampala right away from 2023, and then using these constants that have been given to us. Number 2 is to calculate the expected demand in 2030. Then number 3 is to determine the year when demand will double the 2023 level. So let's look at the solutions. So number 1, we are going to be looking at the model given to us, or the formula is P naught times 1 plus R, okay, power t. And t is in years, R is in percentage. P naught is the power that is available at the start of our projection. So we are given that P naught is equal to 1,200 megawatts, and R is 7 out of 100, giving us 0.07. Therefore, the formula to do this prediction is going to be 1,200 into 1 plus 0.07 power t. And therefore, the formula becomes P of t 1,200 into 1.07 power t. So this is the formula that was required of us. So that is number 1. Number 2, task number 2 is to calculate the expected demand in 2030. So we started our projection. Start of projection is 2023. And then end of projection is 2030. So how many years do we have? So let's do side work. So 2030 minus 2023. So this becomes 7 years. So meaning we are going to project the demand after 7 years. So what does that mean? Therefore, P from P of t, okay, equivalent to 1,200 into 1.07 power t, we shall just substitute in the value of t. We shall substitute in the value of t. So P of 7 years will be 1,200 into 1.07, okay, to power 7. And when we press on our calculator, this gives us 1928 megawatts. Please remember the units. So expected demand in 2030 will be 928 megawatts of power. Great. So we continue. Number 3, we have to determine the year when the demand will double the 2023 level. What is the 2023 level. The demand in 2023 was 1,200 megawatts. So if it doubles, that means double becomes 2 times 12,000, giving us, 2 times 1,200, this will give us 2,400 megawatts. So we want to determine the time when the demand will be 2,400 megawatts. Therefore, from the equation, P of T equivalent to 1,200 into 1.07 power T, we shall just put P of T equate it to 2,400, and then we calculate for T. So what does that mean? I'm going to put 2,400 equivalent to 1,200 into 1.07 power T. So I'm going to divide by 1,200 both sides. That and that will go. So I'll have a 2, meaning I'll have 2 equivalent to 1.07 power T. So what do I do to get the value of T? I take logarithms both sides. So take log to base 10 both sides. So what does that tell us? It means log base 10 of 2 will equal to log to base 10 of 1.07 power T, meaning T will equal, okay, let me just first do it, to base 10 of 1.07 will equal to log 2 base 10. So divide by, I want to get T, I divide both sides by log 1.07 base 10 divided by log 1.07 base 10. So this and that will go, and then our T will equal to what? Log to base 10 of 2 divided by log to base 10 of 1.07. And then this from our calculator, it gives us 10.2 years approximately. So 10.2 years approximately, what will that year be? Okay, so what will that year be? That will be in, so I will just have to get 2023, I add 10 years, this is approximately 10 years, and then this will give us 2033. So the year when the demand will double the 2023 level is 233. So in 2033, the demand of electricity will double the 2023 demand. The 2023 was 1,200, and in 2023 we shall have 2,400 megawatts as power consumption demand. Thank you, members. Problem number 2 says, a solar farm in Soroti uses panels that degrade in efficiency by 1.5% annually. The initial efficiency is 22%. The farm manager wants to know when the panels will reach 18% efficiency and the threshold for replacement. So when they reach 18%, there is the threshold for replacement. So let's look at the tasks that are required of us to perform. Task 1, model the efficiency as A of T equivalent to E naught times 1 minus D power T, where E naught is 0.22, okay, that is from the 22%, and D is equal to 0.015, okay? So that is the model that predicts the efficiency decay of the solar panels. Now, task number 2 is to solve for t, that is going to be in years, okay? And we shall see what application does this come from, either indices, logarithms, or any other, but we are going to see. Then 3, convert time into months for precise maintenance scheduling. So let's look at this problem. Now, we are told to model the efficiency decay as E of t equivalent to E naught times, okay, 1 minus d power t, where E naught initially is 0.22 and d is 0.015. So let's look at what that model says. So from number 1, the model becomes E of t equivalent to E naught is 0.22 times 1 minus 0.015 power t. So what does that become? So finally, it will be E of t equivalent to 0.22 into 0. If I get 1 minus 0.015, I will get 0.985 power t. So that is task number 1. That is the model that we shall use to predict. So I can say is the model used to predict the efficiency decay in this scenario. So let's go. We solve for t in years. Number 2, solve for t. So solve for t in years for E of t equivalent to 0.18. So when E of t is equal to 0.18. So I'll just say from the model, E of t equivalent to 0.22 into 0.985 power t. If this is 0.18, then it shall equal to 0.22 times 9.985 power t. So if I divide both sides by 0.22, divide by 0.22 by 0.22. So this and that will go, and we shall remain with 0.985 power t equivalent to what is this going to be? This is going to be 18 out of 22 if I multiply by 100 up and down, like here. So you'll find that it still doesn't change the mathematical meaning here. So I take log to base 10 both sides, because that's what our calculators can easily work with. Don't take log to base any other. Take logarithm to base 10 because that's what your calculator can handle. So we take log to base 10, so we'll have of 0.985 to power t, and this is equal to logarithm of 18 out of 22 base 10. So what does this give us? T will be log base 8, log of 18 out of 22 to base 10. We are dividing everything by log 0.985 to base 10. So T will be 13.3 years. So since each month has, since each year has 12 months, so I'm going to multiply by 12. So multiplied by 12, then we shall have it as 160 months. But it was required in years. So, but if you want to change it to months, then this is what you can have. So part number 3, it required us to convert into months. So meaning, I know 1 year has 12 months. What about 13.3 years? It means 13.3 times 12, and this gives us 160 months. And that's all.